Hello everyone, myself Supriya Ghadke. Today I am discuss the shortcut method, case second. So case second is uh, for the differential equation phi of dy is equal to f of x when f of x equal to sin of ax or cos of ax. If our function is of the type sin ax or cos ax where a is constant, then our pi, that is particular integral, is 1 upon phi of d square sin of ax is equal to 1 upon phi of minus a square. Here we have to replace d square by minus a square into sin of ax provided phi of minus a square not equal to 0. And similar for the cos x. So pi is 1 upon phi of d square cos of bx is equal to 1 upon phi of minus a square. Here we have to replace d square by minus a square cos of ax provided phi of minus a square not equal to 0. Here we have to only remind that we have to replace d square by minus a square, not the minus a bracket square. That is not the right one. Here square of the square of a and then give the negative sign. So minus of a square, not a minus a bracket square. That is the minus a square. Okay. So don't replace d by anything. Keep d as it is in the expansion. So only we have to replace d square by minus a square. So so here we have to replace d square by minus a square. If the term is d cube, then we have to convert d cube as d square into d. Okay. So we have to convert d cube as d square into d and put the value of d square, that is minus a square, and d as it is. So if there is the term d cube, we have to write this d cube as minus a square into d. If the term is d raised to 4, then we have to convert this term as a raised to 4. So d raised to 4 we can write d square of square. So d square is minus a square. So minus a square bracket square is a raised to 4 because minus square is plus, so that is a raised to 4. Okay. So one note is here, 1 upon d f of x equal to integration of f of dx. So 1 upon d is nothing but the integration of that function. Okay. Also one thing is there, if the phi of d is of the form ad plus b and here f of x is sin or cos x. So we have to convert that form ad plus b to the square term. So to make the square term here, we have to rationalize this term. So here multiply and divide by this term with negative sign, that is ad minus b and ad minus b. Multiply and divide this term, we get ad minus b upon ad plus b, ad minus b into f of x. So that is equal to ad minus b upon a square d square minus b square into f of x. Okay. So now next is example, find pi of d square plus 2d plus 1 into y is equal to 4 times cos of 2x. Here phi of d is d square plus 2d plus 1 and f of x is equal to 4 cos of 2x and here a is 2. So pi is 1 upon phi of d f of x. So that is equal to phi of d is d square plus 2d plus 1 and f of x is 4 cos of 2x. After putting the value, our expansion becomes this. So here we have to replace d square by minus a square. Here a is 2, so minus a square is minus 4. So we have to replace d square by minus 4. So that is equal to this 4 as it is, 4 upon this d square replaced by minus 4. So minus 4 plus 2d plus 1 cos of 2x, that is equal to 4 upon. So 2d as it is, minus 4 plus 1 is minus 3. So 4 upon 2d minus 3 cos of 2x. Now next is, now we have to convert this term in the quadratic form. So to make this quadratic, we have to multiply and divide by 2d plus 3. So this 4 as it is, 2d plus 3 upon 2d minus 3 into 2d plus 3 into cos of 2x. This is the form a plus b, a minus b. So a plus b, a minus b is a square minus b square. So by using this formula, we get numerator as it is 4 2d plus 3 upon, here we have to use the formula, so that becomes 4d square minus 9, because here we have to use a square minus b square formula, and this function as it is cos of 2x, so that is equal to, now here function is in the form cos or sine, so here is the cos function, and in denominator there is the term of d square, so here we have to replace this d square by minus a square. A is 2, so minus a square is minus 4, so replace d square by minus 4 here, so that is equal to 4 into 2d plus 3 upon 4 into minus 4 minus 9 cos of 2x. Okay, now our pi becomes that 4 times 2d plus 3 upon, so 4 into minus 4, that is minus 16, minus 16 minus 9, that is minus 25 into cos of 2x as it is, so that is equal to minus 4 upon 25. So we have to write down separately here 2d cos 2x plus 3 cos of 2x. So now next is, we have to apply that d on this function, because we have to find pi, and pi is when final pi, when we get, when the d and integration terms are removed from the that expansion or that equation. So we have to remove this d term. So d is the derivative, and we all know the derivative of cos of 2x. So derivative of cos of 2x is minus sine of 2x, and derivative of 2x is minus 2. So this term becomes, that is minus 4 upon 25 as it is, in bracket that 2 as it is, and derivative of this term is minus 2 sine of 2x plus 3 times cos of 2x, that term as it is, that is our pi. So our pi is 4 upon minus 25 minus 4 sine of 2x plus 3 times cos of 2x, that is our pi. So now if case fails, if phi of minus a square equal to 0, then 1 upon phi of d square sine of ax equal to x upon phi dash of minus a square sine of ax, and phi dash of minus a square not equal to 0. As we doing in the case first, same here we have to do. First we have to calculate the phi dash of d, and then replace d square by minus a square. If that term is non-zero term, then our pi is x upon phi dash of minus a square sine of ax. Okay, so same for the cos x. So find derivative of phi of d and replace d square by minus a square here. Same we can do in the case first. Similarly for the cosine function, so 1 upon phi of d square cos of ax is equal to x upon phi dash of minus a square cos of ax. So phi dash of minus a square not equal to 0. So now here one example is there. Find pi of d square plus 1y is equal to sin x. Here a is equal to 1. Replace d square by minus 1. Here a is 1, so we have to replace that d square by minus a square. A is 1, so we can replace that d square by minus 1. Okay. So our pi is 1 upon phi of d f of x, that is equal to 1 upon d square plus 1 into sin x. So here d square is minus 1. So minus 1 plus 1 is 0. So that becomes 1 upon 0 sin x. So here case fails. So we have to calculate the derivative of phi of d. So phi of d is d square plus 1. So derivative of this term is 2d. So so we can multiply the x to this term. So x upon 2d into sine of x. So we can directly apply 1 upon d, because 1 upon d is nothing but the integration. So integration of sin x is minus cos x. These two term as it is, x upon 2 as it is, and 1 upon d is the integration. So integration of sin is minus cos. Rearranging the term, we get minus x upon 2 cos x. Okay. So now next is the formulae. These are the standard sum formulas. These formulae are obtained by solving these expansions or these equations. These all are the case fail examples of case failure. So after solving, we direct get the result. We can put direct result here also. Okay, thank you for the watching video. If you don't subscribe the channel, please subscribe the channel. Thank you.